Hello, I am Henrique Andrade, Master's Candidate at the Universidade de Pernambuco. Together with Professor Bruno José Torres Fernandes, we discuss an approach for synthesizing satellite images out of historical cartographic documents, presenting a more familiar look for the observer. Using an image-to-image translation method, we propose adding an intermediate step, which consists of a common visual representation between the two endpoints of the framework. Furthermore, we discuss the role of supporting semantics for the given task and the use of multidisciplinary support from the literature. Finally, we compare different approaches and results, and we debate the importance of architectural and geological precise semantics for more accurate historical representations. Historical maps are culturally rich and socially significant documents with which humans organize and communicate the spatial knowledge of the world. Their study is as revealing and as rewarding as that of any other work of art, literature, or science. As maps are designed by one society to represent and guide its interests, they serve as strategical documents that yield political representation to those communities there depicted. Historical maps are an irreplaceable primary source of geographical and political information from the past. The geographical documentation of some community in the past reassures the importance of its present existence. Likewise, the omission of communities in these documents erases them from history. Furthermore, maps serve as tools for controlling historical hegemony. The understanding of old maps' complex importance and implications requires us to bring them to the center of historical inquiries. Contrasting with the current day tools for mapping regions, such as the use of satellite imagery and LiDAR scanning, historical maps are products of manual labor. The art of elaborating these documents traces back to almost a millennium ago. As a consequence of the evolving drawing techniques from primitive and often distorted spatial representations to documents accurate to the centimeter, information presented in old maps might not be easily read by the ordinary observer. Additionally, historical spatial data is not as easily accessible as modern maps are. These documents are sparsely available on the internet or remotely found in museums and few public collections. As the reconstruction of maps depends on the available data of a desired region, literature discusses the application of a sort of computational methods. Nevertheless, the task of synthesizing a satellite-like image as a more up-to-date version of a map imposes a problem. A texture-based approach needs contextual representation of some dated urban architecture layouts, including its long-modified natural surroundings. In image-to-image translation, segmentation maps are often used as context-driven inputs. Other works have used segmentation labels to generate images in different applications. We consider context to be the localization of textures to reproduce visuals from the time period of the analyzed map. Context brings semantics to our architecture, which yields a more convincing synthesized image for the observer. In other words, gathering our system's inputs requires supporting data that justifies the use of such inputs. It was only during the 20th century that the map production shifted from handcrafted work to be created by computers. Current-day digital maps platforms provide many manipulation tools, such as dynamic text labels and colors, facilitating interpretation for the reader. Conversely, printed maps only counted with a legend and other reading aids found within the actual document. Supporting visual aids in printed maps are a rich source of context, as they describe details about the terrain or the types of land occupation. In addition, architectural and anthropological documentation of the site can also aid as a supporting source for context. In order to approximate the input's context to the desired output, textures need to resemble that of the time's urban configuration. In most cases, current-day satellite images may not reflect the setting of that region in the past. especially regarding city maps. To overcome changes in urban landscapes throughout time, a suggestion would be extracting textures from small towns around a region in analysis. With supporting references, satellite images from other regions of the globe can also serve as inputs. Proposed by Isola et al., Pix2Pix is a conditional generative adversarial network, a framework for image-to-image translation that is not application-specific. One of the many purposes discussed by its authors is the translation between top-down street maps to satellite-like images. Therefore, as we have our segmentation maps, we can perform the image-to-image translation from label maps to satellite-like images, using the Pix2Pix method. The Pix2Pix architecture consists of a generative network G and a discriminator network D. We use G to learn how to translate segmentation maps into satellite-like images, while the discriminator D judges the results, classifying them as real or computer-generated images. As the framework is a supervised method, inputs are provided in pairs of the expected satellite-like image and its label map. The objective of a conditional GAN can be expressed by the equation in the screen, where X is our segmented label map input, Y is our satellite image output, and Z a random noise vector. As proposed by the Pix2Pix method, the generative network G's objective function uses a L1 distance, and it is tasked to fool the discriminator D, while remaining near to the ground truth output. While G aims to reduce its loss function and D aims to raise it, the Pix2Pix's final objective can be written as the equation on the screen, where lambda is a constant to control artifacts on the CGAN result. Different inputs may be more appropriate for a desired representation. Textures depicting urban settings will likely yield a more realistic urban-like output, as natural landscapes textures will probably represent nature better. As each divergent input sets may be better at representing some specific classes, our solution proposes a merge of different training results. We first generate different label maps, we then apply Pix2Pix to each of the results. And finally, we merge the translated label maps into one final image. To merge, we specify which label each translated image was trained to focus. The result is a composition of regions of interest from the inputs. We evaluate each of the pixels P from the generated image using the respective network GN and compose the final image Y as described by the condition on the screen. For this work, we use a map from 1808 Recife, Brazil. Satellite images were obtained from Google Earth and were segmented by hand. We executed two experiments with different sets of inputs. The first set contains images of current-day Recife, hence a more predominantly city-style imagery. Thus, the urban setting is our label of interest. The second set covers more rural areas and natural landscapes from areas around Recife. We compare our results with the output of the state-of-art Pix2Pix. Comparing those results with the contextualized outputs from our first experiment, one can observe textures from a particularly modern urban setting. Other visual elements resemble settings yet to exist and do not reflect the mapping analysis period of time. In parallel, the second experiment results display a focus on synthesized natural aspects. As the second set of label maps does not contain dense urban settings, buildings were poorly represented when compared with the results from the first experiment. A combination of the results of both experiments shows a closer representation to the description of the object in analysis. Merging results, considering the pixels labeled as urban settings from the first experiment, and applying them to the second experiment results yields a trustworthy output, more recognizable than the previous results for the observer. Our results allude to a close visual to what Recife must have resembled in the past. This work casts a light over this field of study. It employs computer science to a social application, where it may serve as an exceptionally necessary tool for historians and other scholars. The reconstruction of such documents impacts post-colonial debates and the civil engineering industry. Presenting a version of one's surroundings from the past may assist in the understanding of changes that influenced society to its current state. It may also point to where it should go, either to repair errors from the past or to avoid errors in the future. In the figures on the screen, we can observe the changes in urban settings between our synthesized image from 1808 and the satellite image from 2020. Advancing this work, next steps would involve generating a higher definition for the resulting images. Furthermore, a deeper examination of the satellite imagery extraction, corroborated by specialized literature, has been proved to yield trustworthy synthesized images. We would like to express our gratitude to the agencies that allowed the development of this work, and also to your attention. Thank you.